So we talk about combinations in our section 2, which is a little bit different than a permutation, because overall, a combination is just a set of objects where the order is not required. In other words, order does not matter, which is different than what a permutation is. The biggest difference is that a combination eliminates any kind of permutation that would look identically the same. So for example, if we had two, I don't know. Well, switching the two zeros or two O's is going to be the same thing. So there would only be what, three combinations here? 1, 2, 3. Yeah. No, not even. It just is using an idea that anything where the order here doesn't really matter. So as long as you're using all of these, so it's going to be the same. So it doesn't matter whether we have it written as TOO, OTO, or OOT. Fundamentally, those are the same kind of combination. It's just the order doesn't matter for it. So all of these are the same in the context of a combination. So what you need to do is you need to identify whether a question actually is identifying whether the order matters or not. And there's 3 ways of notating it. There's a bracket where you have literally an N over an R. I know that my really bad notation problem is I'll write it as N over R. Like I'll actually write it as a division, but it's not, you're not supposed to be writing that division. If you do by accident, I'm fine with it. I totally understand. It's just it's not a fraction, just N over R. It's same kind of idea, that N, no matter what it is just the total number of objects. The R value is how many are being used. So you'll notice in the question, or in this factorial notation, it looks very similar to the NPR. Which is that one. The biggest difference is this R factorial part, which just helps to identify that, okay, well, it kind of eliminates anything that would be the same, using the same kind of letters or not whatever kind of characters, elements. It eliminates any of the elements that are using the exact same ones. So that's kind of the biggest difference between the permutation and the combination. You access your C the same way that you access your P, by pressing that PRB button. PRB. But you do have to use your arrow to actually access it. So first things first, let's go with the factorial notation for this question. How many sets of 4 golf clubs could be selected from a golf bag containing 11 different clubs? So instead of taking the entire bag, if you're only allowed to take 4 of them onto a course, which actually some kind of competitions will say that that's what you can do, or what you have to do, we have 11 total objects, 11 total clubs. We can only take 4, but it doesn't matter which 4. Of course, your selection, typically you want to have a putter, you want to have a driver, you want to have some kind of wedge, and you probably want to have an iron, which kind of complicates things a little bit further, but we'll talk about those ones later. But long story short, be 11 factorial divided by 11 subtract 4 factorial, 4 factorial. So I'm going to show the long way, and then we're going to do it just by calculation. because I just want to get us into the habit of being able to use the formula. So 11 factorial would be 11 times 10 times 9 times 8 times 7. And oh, this to me earlier. I'm going to leave it at 7 because 11 subtract 4 is 7. So that will allow me to actually cancel that 7 factorial off. I'm going to go a little bit further, and that 4 factorial that would be tacked on at the end, I'm going to expand that one out as well so that I can cancel things off as well, or with it. For example, a 4 and a 2 is 8. So I'm going to completely cancel that off. And then the 3 and the 9 will also reduce, which means I'm just going to have that 1 in my denominator. 11 times 10 times 3 is 330. When I use my calculator, which is absolutely going to be your preferred method, I'm going to type in 11 and use my C with my calculator. So I type in 11, I press my PRB, so press 1, 1, I press my PRB button. I scroll over to my NCR, press probably enter or the equals, and then I type in 4, and I still get 330. Now that we've kind of done this, we'll leave this for a little bit and we'll do it mainly our strict calculation. So in a class of 34 students, needs a committee of 5, plan a fundraiser for a school charity. How many different committees could be selected? Well, if we have 34 total students, and we only have to select 5, it doesn't matter which 5. It's not like the first person selected gets 50% of voting power and all that kind of jazz. If the order doesn't matter, we're going to use a combination. So 34 C5 will be 278,256. Now, since you're grade 12s, I'm going to teach you a little bit about lotteries and gambling. First off, don't do it if you don't have money. Don't be gambling if you're expecting to win a whole bunch of cash, because you're going to be losing a lot of money. And I'm going to show you exactly a question that kind of proves this. So in Lotto 649, which is one of the bigger Canadian lotteries, you choose any 6 numbers from the numbers 1 to 49. Doesn't matter how you pick them, you just select them. So for example, you could literally just pick the numbers 1, 2, 3, 4, 5, 6. And then when the draws are selected, the 6 could come out first, then the 2, then the 4, then the 1, then the 3, then the 5. Well, great, then you won. But the order that it comes out of the machine doesn't matter. So if we have a total of 49 numbers to select from, and we have to take 6 of them, that's 49C6. 49C6. Which means there are 13,983,816 different tickets that could possibly be issued. Now, with the Lotto 649, you're also given 3 of them. Each ticket, you're given 3 or unless it's been a long time since I've bought a lottery ticket. I know Lotto Max gives you at least 3. I think Lotto 649 does as well. Let's say it does. So each ticket, you have 3 unique number combinations on your thing. So that reduces the amount of number of tickets that you would need to buy to 4,661,272. What you don't know is every single ticket, again, it's been a while, so they might have changed the prices, but it's $5 a pop. Which means if you want to guarantee a win, you want to guarantee that one of your tickets is going to win, you would have to spend $23,306,360 to guarantee a win. No one is going to finance you $23 million. If you only spend $23,306,355 and that one last ticket that has your winning 6 numbers has or is the winner, you've just wasted $23 million buying. Which is why it's such a huge deal when people actually win the lottery. The chances of winning are 1 out of 4,661,272, and that's just for Lotto 649. There's a whole bunch of different lotteries around Canada. I'm just going to pause the video really quick and see what our Lotto 649 is going to be this week. So for this week, which is being drawn on Wednesday, the prize is $25 million. So in Canada, as far as I understand, lottery winnings are not taxable, but you would be, if you won and you guaranteed your win by spending $23 million, you would be getting $2 million. Well, 1.7 approximately. Of course, I can't tell you what to do with your money. A lot of people do try and go with that game of chance. All I can say is be responsible. When you are able to buy lottery tickets and do gambling stuff, be responsible, please. Please. Okay, so there's my public service announcement. Now we're going to talk about combinations from different sets. So this is actually going to be applying the same kind of idea as our fundamental accounting principle. And I'm just going to call that the FCT. Or FCP, sorry. Where we had so many options for one thing, and we multiply it by how many options for a second thing. So if we had 4 pairs of pants and 5 shirts, that would be 20 different outfits that we can make. When we have 2 or even more separate kind of sets, we're going to follow that same kind of understanding. For example, if we have 12 boys and 8 girls in math club, yes, there are actual math clubs around, and they're actually pretty cool. I know I'm a nerd. I get to deal with that. And how many ways can a committee of 3 boys and 2 girls be formed? Well, what that means is from the 12 boys, you have to select 3 of them. And from the 8 girls, you have to select 2 of them. Now, proportionally, that is still correct because a quarter of the boys are being selected and a quarter of the girls. So that's why there's obviously more boys. If you type this into your calculator, 12C3 is 220. 8C2 is 28. So there's 220 ways of just getting the boys. There's 28 ways of just getting the girls. We multiply them together. We find out how many possible committees there would be. 6,160. And that's all there is to that. We go further into what I hope. So yes, this kind of stuff does talk about gambling, but at the same time, we're talking about just kind of general play. For example, we can talk about card hands, because I think that everyone should know how to play some card games, even if it's just solitaire. But obviously other games can be more fun. My wife and I play Skippo, which is actually really fun. But anyway, so a 10-card hand has to be dealt that contains 3 hearts, 4 clubs, 2 diamonds, and 1 spade. Well, the question is, how many hearts are there? How many clubs are there? How many diamonds are there? And how many spades are there? In a standard deck, there are 13 of each suit. So for the hearts, if we can only select 3 of them, it would be 13C3. For the clubs, it'd be 13C4. Diamonds, 13C2. And for the spades, 13C1. We'll type all that into our calculator. 13C3 and 286. Don't know why my stylus went weird like that. 13C4, 715. C2, 78, and 1 is 13. So 286 times 715 by 78 by 13. Uh, 207,352,860. That's how many 10-card hands are possible from a standard 52-card playing deck. And that's with this stipulation. If we talk about just a standard 52-card deck, having a 10-card hand, yeah, we're at about 1.6 billion. Right? 3, 4, 5. No, 15 billion. So about 16 billion different 10-card hands. 207 million of them have this strict stipulation. Alrighty. So overall, I usually do this one as a class, and we have all the information. I can't exactly remember how many people are in class. I know that you guys have. I can't even remember. But let's do some hypothetical. Say that we have 9 females and 7 males in your grade 12 class. If the principal wants to just select 5 students, how many selections are possible? Well, if there's no stipulation on it, we just have 16 students, and just 5 of them need to be selected. So 16C5, 4,368. If we add some extra requirements onto it, how many selections are possible if you have to have 2 females and 3 males? Well, let's actually change that around, because I believe that there's more females, so we'll change that. So 2 males and 3 females, especially because we have more females, so you want to have some kind of representative. 2 males means 7C2. 3 females means 9C3. Seven C2 is 21. And 9C3 is 84. So 21 by 84 is 1,764. Now, because of the YouTube video, I'm not going to use names, but if one female student is named Lola, I don't know. How many 5-member selection committee of Lola, 1 other female and 3 males are possible. So if we're just talking about the females, there's a total of 9 females and Lola is one of them. That means that there are 8 females left. One of the selections is already Lola, so we can't use her again. And there'd be 1 female left to select. Or 3 males, well, that's going to be 7C3. Again, I know that's not representative, but I just want to do an example. 8C1 is 8, and 7C3 is 35. Multiply them together, there'd be 280 different grad committees. What about if Carly is writing a pre-calc exam and the instructions say that she must answer a specified number of questions for each section? So there's going to be 2 sections. So there's the part A and a part B. How many different selections are possible if she has to answer 2 of the 4 questions in part A and 3 of the questions in part B? So for part A and part B, part A, there's 4 questions. She has to select 2 of them. It doesn't matter the order that she does them. She could do question 4 and then go back to question 1. And of the 5 questions in part B, she has to select 3. So 5C3. Again, it doesn't matter the way that she selects those 3 from the 5. 4C2 is 6. 5C3 is 10. There would be 60 different ways that she could finish her test, just by selecting 2 from 4 and 3 from 5. Now, here's the difference. What about if she has to select 2 from the 4 questions in part A and at least 3 of the 5 questions in part B? Well, similar kind of setup. The biggest difference, if she has to select 3 from the 5, we know that that's going to be 6 times 10, which is 60. But if she has to select 2 from the 4, and at least 3, it means that she could also select 4. And that would turn into a 6 times 5 situation, which is 30. 5C4 is 5. Or she could select all of them. Which means 6 times 1, which is 6. Yeah, all of those possibilities, we get 96. Last one, hardest type of stuff. It's actually not as bad as you think it is, but we're going to express as factorials and simplify. So the first thing I'm going to do is I'm going to just split this into two sections just so I try and not have any overlap. Remembering that NCR is n factorial over n subtract r factorial, and we're going to need a P as well. And PR is n factorial over n subtract r factorial. Those aren't absolute, they are supposed to be rounded brackets. Okay. So let's have some fun. So n subtract 1 C3 multiplied by 1 divided by n subtract 2 C3. Well, let's just plug things into our equation. So n subtract 1 is going to be the n in this first one. 3 is going to be the r. So we're going to have n subtract 1 factorial divided by n subtract 1 subtract 3 factorial. 3 factorial. The second one is we're going to have it as 1 divided by, well, I'm not going to actually write that as divided by that way. I'm going to make my life a little bit easier. I'm going to say it as multiplied by 1 divided by n subtract 2, which is the n in this one, factorial, over an n subtract 2 subtract 3 factorial, 3 factorial. Alrighty, nice, long, convoluted. Could probably move all of it over. Just to be a little more centered. So first things first, n subtract 1, there's nothing to simplify. So I'm just going to have it as n subtract 1 factorial. I'm going to try and take this one as slow as I possibly can. At the same time, try and keep in mind about time. And then we have n subtract 4 factorial 3 factorial. Multiplying by 1 isn't going to change anything, but dividing by a fraction here means multiplying by the reciprocal. So we're going to do that right away here. The n subtract 2 subtract 3 will be n subtract 5 factorial. Three factorial on that numerator over an n subtract 2 factorial. The hardest part here is we're going to be doing some canceling here. We can see one thing that can cancel right away, and that's that 3 factorial. But beyond that, this is where it's going to actually get complex. Because we have to think about what does everything expand out as. For example, n subtract 5 factorial right here would be n subtract 5, then n subtract 6, n subtract 7, n subtract 8, n subtract 9, n subtract 10. And the more that we continue, just so you know, I won't really give you anything that's going to go more than 3. So just be cautious of that. An n subtract 5 factorial, if it's not going to cancel off with something that's already here, well, this one's probably going to be safe to leave alone. So we're going to have an n subtract 5 factorial left right there. Whereas if we look at this n minus 1 factorial, 1 less than n minus 1 is n minus 2. And because that would be in a numerator, and this n subtract 2 would be in the denominator here, we're going to be able to cancel something off. So we're going to have that n subtract 1 factorial. Oh, sorry, not factorial. Expanding it out, n subtract 1, then n subtract 2. That's going to allow us to cancel off with that n subtract 2 factorial in the denominator in that second fraction. Put that there. So that entire thing is going to cancel off. So the last thing that we need to look at is this n subtract 4 factorial. Well, 1 less than n subtract 4 is n subtract 5, which is exactly what will be left in the numerator here. So that's going to help us do this nicely. N subtract 4, and then we'd have an n subtract 5 factorial. It's a 5. Our n subtract 5 factorial cancel off with our n subtract 5 factorial, and we are left with an n subtract 1 over an n subtract 4. Not ideal, especially since we're not simplifying or anything, because this one, or not having to solve, this one is just simplifying. Whereas our next question, and this is literally it, sorry. This is it. I'm not going to ask for any restrictions on here because we just know that our n, basically we can't have negative n. So anything that would make these negative just won't be possible. Actually, that's probably going to tie really nicely into this. We have 720 multiplied by NC5. So NC5 means n factorial over n subtract 5. Undo that. N factorial over n subtract 5 factorial, 5 factorial equals n plus 1 p5. So that's why I wrote down this one, because our n is n plus 1 factorial over, oh, that wasn't, am I able to unrecognize? No, okay, I'll have to write that again. Over that n plus 1 minus 5 factorial. Plus 1 factorial. Notice how I don't have that 5 factorial because that's not what the permutation is stating. So let's see what we got. FYI, 5 factorial. If you type that in your calculator, it should be 120 if I remember correctly. Yeah. It also means that we can reduce it with that 720. Because 120 goes into 720 6 full times. So that 5 factorial is gone. So we're going to have 6. And then we'd have it being multiplied by n factorial over an n subtract 5 factorial equals n plus 1 factorial over n subtract 4 factorial. Again, just like our question here, the hardest part is going to be seeing, okay, what do we expand out so we can actually do something with? Well, if we expand out n factorial, 1 less than n is n minus 1. N minus 2, n minus 3, n minus 4. Okay, we could technically cancel that off with that n minus 4, but it's going to make our life kind of heck. N minus 5 factorial is n minus 5, then n minus 6, n minus 7, n minus 8, n minus 9. Well, that's not going to help. Our key is actually going to be in these two. And sometimes it does take practice to find out that bit of information. So I'm just going to rewrite that right-hand side, or sorry, left-hand side. I'm writing with my right hand. So n plus 1 factorial, oh, I forgot about there's an equal in between. N plus 1 factorial, 1 less than n plus 1 would be n. And that's going to be the key, because now we have that n factorial in that numerator there. I'm going to literally leave, I'm going to make this really big there for a reason. N minus 4, 1 less than n minus 4 is n minus 5. So that's going to be really nice to work with. N minus 4, n minus 5. And then it would technically continue. That's why we put the factorial with that n minus 5. And now we're going to do some work here. We're going to divide both sides by n factorial. Because dividing both sides by n factorial means n factorial there is going to cancel off with the n factorial there. I do it to both sides, that n factorial gone with that n factorial. If I do the similar thing with multiplying both sides by an n plus 5 factorial, sorry, not n plus, n minus 5, sorry. That n minus 5 is going to cancel off with that n minus 5 factorial. Same thing there. And overall, we're just left with a 6 on the left-hand side. An n plus 1 over an n minus 4 on the right-hand side. And now we just go back to our rational equation, rational function stuff to solve. Get rid of our denominator, which means multiplying both sides by an n minus 4. Make our life easier. Sorry, we'll cancel that off first. Make our life easier by distributing to get a 6n minus 24. Equals an n plus 1. Move our n's over, move our 24 over. So subtract n, add 24. And we'd have 5n equal to 25. Solving for n, divide by the 5, n equals 5. Really long and convoluted, but basically if we plug 5 into all this, so 5c5 is 1. So I just want to kind of check. 5c5 is 1. So the entire left-hand side would just be 720 times 1. The right-hand side would be 5 plus 1, p5. So that would be 6 p5. And if you type into your calculator, 6 p5, 720. I know, long and convoluted, but at the same time, really satisfying when it actually all works out. All right. Yeah, you have some questions to work on, and go have some fun.